All right, happy Tuesday. This is a B day Friday, which makes this a really weird week because since we had Monday holiday, we've got 3 B days this week and only 1 A day. So tomorrow is the only A day of the week. Just one of those weird things they did when they swapped the A and B from last week. But we'll manage. Okay, let me put up on the screen our math this morning. Looking here, let me see. I've already gone into this is our algebra class. I've already gone into our algebra class. Let's look in our grade screen to see what's due this week. So we see last week we had the pretest, the algebra 1 review, and revisiting functions. Now I did this on purpose to show you. Here's my fake student. He got a 35 on the pretest, an 80 on the review, and 100 on the revisiting functions. Now look at his grade in the class. 100%, because these two are both practice grades. Review, pretest, don't count towards the semester grade. So even though Mr. Fake Student here didn't do too well, still got 100 in the class right now because this is the only one that counts towards your semester grade. Now this week, all these things count towards our semester grade. We have a quiz over the earlier stuff here of the review and revisiting functions. So here's a quiz. We won't review the quiz in class. You can do the quiz. And we have 2 lessons this week, writing the equation of a line and comparing functions. So let's go look at these 2 lessons here today. Oh, wait, no, just go to activities. All right. So writing the equation of a line here, 1.05. Let's take a look at that. You guys should be experts at writing the equation of a line now, but we're going to look at the variations of that. You could probably write a y equals mx plus b line pretty nicely, right? Because that's slope-intercept form. There's a little video for you to watch. I'm not going to play that in class because you have access to all of this in your Buzz lesson. But it's talking about the navigator of an airplane has a responsibility setting the onboard computer at the plane's correct trajectory prior to landing. It's like you can use equations for that. If I forwarded this, it's doing some airplane lines to get the plane in position to land from distance to airport. So it's using equations lines, but you can watch that video. Here's our questions that we're going to be able to answer. What methods are useful to create the equation of a line? And what restrictions may be necessary to the domain and range of linear equations? So let's get started with this. All right, looking at different forms of linear equations. You say you're an expert at taking the equation of a line and making a graph for it, right? Y equals 2x plus 1. You can do that. You put the y-intercept at 1 because that's the plus 1. The slope is 2, so it's 2 over 1, rise over run. So you can make an equation of a line. I say we've been doing that since junior high. But the goal of this lesson is to move the other direction. How is an equation written from pieces of the graph, such as coordinates of 1 or 2 points, the slope or the y-intercept? So you've learned 2 ways. You know the standard form, ax plus by equals c. We don't use that very often. And the slope-intercept form is the one we're used to the most because that's how we need it to graph it. But what is the equation of a line with a slope of 2 and a y-intercept of -4, right? So y equals mx plus b. Your slope is 2, your y-intercept is -4, y equals 2x minus 4. Not a problem there. Let's see, explaining complete sentences. The equation line can be directly written in standard form using a pair of points, a slope or y-intercept. Check your work. I'll let you look at that because we're not going to cover all of that. All right, here's an example of point slope form. So this is the equation of a line in point slope form, just a generic line. We're going to go through this example right here, and we'll do this together to talk about point slope. So let me write this down. Goes to 2, -1, slope of 2. And we want to write this in standard form, but all we're given, so I'm going to put this up on our screen. All we're given is this point, 2, -1, sorry, and a slope of 2. So, slope of 2. So how do we write that in standard form? Standard form is ax plus by equals c. That's the standard form of a line. Well, if all we have is a point and slope, we could use the point slope formula, which is x minus, well, wait, I'm doing that backwards already. Y minus y1 equals mx minus x1, right? And again, we saw that right here in our equation. I'm sorry, there it is. Y minus y1 equals mx minus x1, right there in our lesson right there. So, okay. So what we have to do is fill in the y1, because those are the numbers we'll fill in, and the slope. The rest of it's just a standard equation. So y minus, what is the y? -1. Let's put that in parentheses because we don't want to mess that up since we're dealing with a negative. M is slope. M is always slope. So slope is 2. And then x, parentheses, x minus the x is 2. Okay, so this is the equation of a line that has a slope of 2 and will pass through the point 2, -1. This will pass through the point 2, -1. Now we need to simplify this. Y minus -1, when you subtract the negative, so this is actually y plus 1 equals, and we can go ahead and simplify that, 2x minus 4, right? We distribute the 2 to both terms inside the parentheses. So we have this equation. We're wanting to get it to this. We said write this in standard form. Well, the standard form, the x and y are on the same side, the equal sign, and on the other side is just the number. So if we move the 1 over, y equals 2x minus 5. We have the x on the other side. Subtract 2x. Subtract 2x. -2x plus y equals -5. Okay, that's standard form. The x and y are to here, and everything else on the other side, -2x plus y. You could also, if you don't like starting an equation with a negative, you could multiply everything by -1 and say this is 2x minus y equals 5. Is that the same line? Good question. Let's graph that. Like multiplying both with -1, does that change our line? We're going to go to Desmos. We're going to graph both of those just to verify for ourselves whether or not. Graphing calculator. Graph. Verify to ourselves that is the same line. So -2x plus y equals -5. That was the first line we had right there. See that? It goes, has the y-intercept of -5, goes up the slope to where it crosses the x-axis at 2.5. Let's graph the other one where we multiplied both sides by -1. So 2x minus y equals 5. Well, look at there. It's the same line. There's the blue line. If I turn the blue off, the red one, they are the same line. So multiplying both sides by -1 does not change the line, does not change the equation. It just changes the look of the equation. So that is a legal, a mathematical move. If you don't like starting an equation with a negative, you can multiply both sides by -1 and make it 2x minus y equals 5. Because we like starting with positive numbers a lot of times. All right. Let's go back here. So this will walk you through the same steps that we did. And they made it times the -1 also, 2x minus y equals 5. So to make the x positive. All right, don't forget with the double negatives. You know, here we put that -1 in parentheses because 3 minus -1 is 3 plus 1, right? So use parentheses when you deal with a negative number with your subtraction so you don't mess it up. Here's another, if you need more on writing the equation of a line with the point and slope, you need another example. Okay, they've got one here you can click and go through. They give you the point -3,5 with a slope of -3. And they'll walk you through another example if you need one. So we won't take class time for that because it's right there for you. All right, let's look at this. Writing the equation of a line given 2 points. So imagine you are a flight navigator trying to determine the equation needed to land the airplane at the airport. So you're trying to figure out what slope to come in. At a horizontal distance of 8 miles from the airport, you're a mile in the air. So that gives us one of our points. 16 miles from the airport, you're 3 miles in the air. So use these values to determine the slope of the flight and then find the equation to land the plane in slope-intercept form. So let me write this down. At 8 miles, we are 1 mile in the air. At 16 miles, we are 3 miles in the air. So first thing to do is calculate the slope, right? So we can use those points. I'll put it up where we can do it together here. At 8 miles away, we're 1 mile in the air. 16 miles away, 3 miles in the air. So we have to determine the slope. Now, if you remember, we can take y2 minus y1 and put it over x2 minus x1 and figure out the slope. That is the slope equation. So y2, we can determine either one of these as y1, y2, right? We could say this is y2. If we do, that means this is x2. You can't do it opposite. But we're going to say this is the first one and this is the second one. So we'll just determine it that way, first and second. So y2 is 3. y1 is 1. So 3 minus 1. x2 is 16 then, since we said 3 was the y2, minus 8. So 3 minus 1 is 2. 16 minus 8 is 8. We can simplify that to 1 over 4. So our slope, m equals, m is 1/4. That is the slope. So if we're wanting to write the equation of a line, we can use point slope because we have a slope now. And we can use either point. So let's just use the first one. So using the same y minus y1 equals m times x minus x1, we can do y minus 1 equals the slope x minus 8. Okay, so this is the equation of a line that will pass through that point with that slope, which means it should also pass through this point because we calculated the slope between those 2 points. We could also write this as y minus 3 equals 1/4 x minus 16. That's just using the other point. These should be the exact same thing. Let's go ahead and simplify them and write them in standard form, because that's what we've been doing with this. Standard form. So y minus 1, we just need to simplify the parentheses. Y minus 1 equals 1/4 x. 1/4 times negative 8 is just negative 2, because it's 8 over 4, which is 2. On this side, we have y minus 3 equals 1/4 x. 1/4 times negative 16, 16 over 4, minus 4. Okay, let's move the 1 to the other side. Over here, we'll move the 3. Y equals 1/4 x. Negative 2 plus 1. Y equals 1/4 x. Negative 4 plus 3. Well, look at there. We've come to the same. This is in slope intercept, right? Slope intercept. That would make it easy to graph at that point. But these are in the exact same line because we came down to the same equation using either point. And then to write this in standard form, cross my T, you have to move the x over, right? Minus 1/4 x, minus 1/4 x. So this is negative 1/4 x plus y equals negative 1. Or again, if we multiply it by negative 1, because we like that positive x term at the beginning. 1/4 x minus y equals 1. And this would do the exact same, it's the exact same equation, so I'm not going to write it twice. So let's look at what we're doing with that now. Let's see. Determine slope intercept. That's it. Y equals 1/4 x minus 1. We did that. Now let's talk about restrictions to domain and range. Okay, so they stopped at the slope intercept, which is fine. Based on the situation when graphing equations and functions, sometimes it may be necessary to note limitations on the domain and the range. Right? Domain's all the x's, range is all the y's. These are called restrictions. So if we look at this problem above, we got these points because we were in an airplane and we were navigating to a landing. So in that case, there's a limitation. The y variable represents the plane's height above the airport, above the ground. It would not be realistic to have a y value that's a negative number because that means everyone's dead and it's plummeted into the ground, right? That would mean the airplane is below the airport or underground if it's a negative number. So in this case, the range can only include positive numbers. Since y cannot be negative, the smallest number it could be would be 0, and that's when it's landed. So solve for x when y is 0 to find the smallest realistic value for x. So we see what is the restrictions at that point. If we have this y equals negative equals positive 1/4 x minus 1 going from slope intercept. If we said the y had to be 0 and could not be less than that, 1/4 x minus 1, 0 equals that. Let's move the 1 to the other side. 1 equals 1/4 x. How do we get rid of our fraction? We multiply by whatever's on the bottom. If we multiply both sides by 4, 4 times 1/4 is 1. Those are inverses of each other, right? 4 times 1/4 is 1. So that would just be equal x, and 4 times 1 is 4. So x has to be 4 or greater. X cannot be less than 4. Y cannot, no, y, there's no this thing. Has to be 4 or greater. That would mean, and y has to be 0 or greater. That's the restrictions. Y can't be less than 0, so it has to be equal or greater than 0. X can't be less than 4, because if it's less than 4, y is going to be less than 0. So y has to be 4, x has to be 4 or greater. So there's restrictions just because of the scenario, because it's an airplane and we're calculating the landing. So that's why we have that in there. Is the equation limited? No, 1/4 x minus, y equals 1/4 x minus 1. There's no limitations except for we're looking at a real life scenario. So does that mean the plane lands 4 miles from the airport? Yes, at the current trajectory it's going. If the pilot follows this trajectory, it's going to land 4 miles from the airport. So they're going to need to change their slope. So they adjust their trajectories during the flight due to a number of real world constraints like wind or turbulence. So be wise for this pilot to change his trajectory. He's going to end up 4 miles down the road on a highway or in a field somewhere. So at the way he's going. So here's another, if you need another example on how to write the equation of a line with 2 points, you can click here and it will give you another example of that. It'll pop open a window and give you another 2 points and walk you through that. So, all right, important note, multiplying the fraction by the denominator eliminates the fraction. So I was just talking about. This has 3/4. If you have a 3/4 x, when you multiply by 4, you just get 3x, because 4 times 3x is 3. So, all right, so there's another example if you need to go through another example. Let's talk about writing the equation of a line given its graph. All right, lines are not bad to write with its graph. It has a video for that. All right, so and you can watch that video. Like I say, I'm not going to do that in class, but all you do is calculate the slope and the y-intercept. Slope and the y-intercept, and you can write it in the slope-intercept form. So if we went over here and we had a random line, let me do it this way. 4x minus 6y equals 3. I probably should make something nicer than that. Oh. How about not 33? There we go. 4x minus 6y equals 30. Can we write the equation of the line? Sure, we can. We find out where it crosses. So it crosses at -5. So if we were writing it in y equals mx plus b form, we know our b, where it crosses the y-intercept, is at -5, because 0, -5. So we can change the b to -5. And now what is our slope? Well, it goes to this point. Where else does it go through a point? Right here, it goes to this point. 3, -3. We can calculate the slope between those two, where we take the y minus the y and the x minus the x. So -3 subtract -5. So -3 minus -5 is 2. So 2 is on top of our fraction. 3 minus 0 is 3. So our slope is 2/3, which we can see that it goes up 2 and right 3. Rise over run is 2/3. So if we change this to 2/3, it's the same line. Just taking a graph, looking at the y-intercept, looking at the rise over run, 1, 2, 1, 2, 3, or you can calculate it with the slope equation, like I did there with the 3, -3. But we can write the equation of a line using a graph. And so here's a video that explains that. If you need a written out, need to watch an example, it's 1 minute and 3 seconds. So since you have access to that, I won't play the video. But you've been doing y equals mx plus b since junior high. Probably got that. Here's more on writing the equation of a line given its graph. If you need more examples of that, it's loading very slowly. Well, something's there. It's like I'm not going to wait on it. It's taking forever. Let me give it another chance, see if it loads better. There we go. It says write the equation of this. So it gives another example. See if you can do this. Right? This has a 1.5 y-intercept. It does not cross at an even number. It crosses at a decimal number or a fraction. But you can still write that. So it has the steps that you go through. See, it's taking these points to figure out things. There's a point that it crosses. So it's labeling those points. It's figuring the slope, rise over run. Rise over run, it goes up 1/2. The y-intercept does not cross. It looks like 1.5. We probably shouldn't assume that. And here's you can check your answer. So you can check your answer right there. So, all right. Basically, they did that since you can't assume exactly what that could be 1.55, right? Oh, excuse me. Could be 1.55. We don't know exactly what the y-intercept is. So use the point slope. You know the slope and you know 2 points. So they wrote it using point slope. So there's another example for you to go through and be able to check your answer. And then the lesson summary. So this is the end of the lesson. The rest of the pages are practice problems. So standard slope intercept and point slope. That's the 3 different forms that we looked at. ax plus by equals c. This one you're very familiar with, y equals mx plus b. And then the point slope, which sometimes we need a refresher on, y minus y1 equals m times x minus x1. And we can rearrange those as needed because we took point slope and we rearranged it to slope intercept and then standard. We can just remove the x's and y's to make it look like we want. So here's the summary that you can use in your notes for any quizzes, tests, anything. You can always use your notes. So here's a great place to get the notes from this lesson because they put everything that we learned right here on one page. All right, and like I said, there's more pages, but these are practice problems for you. So these are the ones that you should do on paper and then check your work. So this one says, write the equation of a line passes through this point, 1, 2, and has a slope of -1/3. What would that look like in standard form? Oh, wow, I moved it. Hey, look at that. Which one of these would that be in standard form? So work that out on paper, figure out, select one, said, oh, I think it's going to be that one, right? And then hit submit, and it says, oh, great. That was just a good instinctive guess. And it shows how you get there. So, and then there's 3 of those, right? So there's another one there. Submit that. There'll be another one So good practice problems. On the next page, there's more practice problems. Using the information given about the line, write its equation in the indicated form, and then see if you're correct. Write the equation of the line passes through this point and has a slope of -5, and write it in standard form. And there where you can check your work and see if you're right. And there's 6 problems there. See there, 7 problems there. Done with that one, try another one. Write this in point slope. Try another one. Standard. So it gives you several practice problems that you can check. Now, if you know how to do it and you're not missing them, you don't have to do all 7 of them. Maybe check and see, now this one's different. This one's off a graph. So maybe you need to make sure you can do a graph. But if you can do those, there's 2 graph ones. But if you got that real easy and you can do that one, maybe you can skip the graph one. So like I said, these are problems just to help you. Do I understand? Do I know how to do this? And if you can do these practice problems when it doesn't count, then you shouldn't have any problem doing it when it does count in the assignment. All right. And then the last page just summarizes, shows you the essential questions again, right there. You click and get those essential questions. It says do the assignment. So if we go to the next one is the actual assignment, start. 1, 2, 3, 4, 5 multiple choice questions, which are the same thing. Write the equation of a line, slope of -2, y-intercept of 5. Or goes through this point, has a slope of 2 in point slope form. So, all right, yes, I want to leave. I know I haven't done it. All right, let's look at our other lesson real quick. Comparing functions. This is an important skill. If we have 2 functions, can we tell what's different? So I won't read all this. Well, no, let's go ahead and read this. X marks the spot. Looks like it's kind of an interesting thing. One of the oldest treasure maps is a copper scroll that was found with the Dead Sea Scrolls. All right, the Dead Sea Scrolls were found back in the 70s. So we have an actual treasure map 50 years old there. Well, a couple thousand years old, but a collection of documents written sometime between 150 and 70 AD, 150 BC and 70 AD. When these Dead Sea Scrolls were written. So this treasure map was found with them, so it's got to be at least the same age. Encoded on the copper scroll were directions to 63 secret locations that held riches of gold and silver. Part of the scroll reads, in the ruin, which is in the valley of Achor, under the steps leading to the east, 40 long cubits, a chest of silver and its vessels with a weight of 17 talents. All right. A talent was like a week's wages, I think. If I remember correctly. To this day, only assumptions can be made about where the treasure lies. They've never went and found this. So math can also be a bit like reading a treasure map. There can be hidden nuggets of math, gold, buried within the sentences of a word problem. And with those clues, you'll be able to derive your own treasure map, which would be a graph of the function. So here's our 3 questions. You could read those. Let's look at page 2. Finding key features. That's the thing. When you're comparing functions, you're going to find their key features. Like what is their y-intercept? What is their slope? How can we compare those? So Zora loves movies. Is going to buy some DVDs to build up her collection. She knows the average DVD costs $21 at her local store. How much would 6 cost? How about 10? May seem like routine calculations, but there's also a function hidden in there. What steps are being taken to find the solution? And how does the 21 come into play? Right? So check your thoughts. The 21, if each one costs 21, if we were writing an equation of that, that would be the slope, right? For every DVD you buy, it's $21. So I need to multiply the amount of DVDs you're going to purchase by the amount they cost. Since each one's $21, this would be the slope or the average rate of change. All right, so she can create a function, which would be function D equals 21 times D, 21D. So if she bought 1 DVD, you put a 1 in for the D, and it's $21. If she wants to buy 6, it's $126. Simple function. So what do D and F of D represent? Right? D is the number of DVDs she's going to buy, and F of D is the total cost. That's the dollars she's going to need. So 126. All right. So, Zora just got a text from her mom. She needs to pick up a gallon of milk while she's at the store. So no matter how many DVDs she purchases, she'll got to buy that gallon of milk, which is $3.50. So how does that affect her function? Well, it's 21D plus $3.50, right? It's still 21 times the number of DVDs she buys, but now she has to add $3.50 on for the milk. All right, so one last item to think about. Is her function increasing or decreasing? Oh, yes, an increasing function or decreasing function. As she purchases more and more DVDs, does the total go up or down? Obviously, it's increasing. The more DVDs you buy, the more money it takes to buy them. So it's got to check your thoughts there. Take a look at all the features. So let's look at all the features from her interpretation. So f of d equals 21d plus 350. So a slope is 21. And the 21 represents the dollars per DVD, or the price of each DVD. The y-intercept is 350, because if she buys 0 DVDs, she's like, I'm not going to buy any today. Still going to have to spend $3.50 for the milk, right? D and f of d, D is the amount of DVDs she purchases, and f of d is her total cost of what she has to spend. And is it increasing or decreasing? This is an increasing function, which when we look at a graph, increasing function is going up. The larger the x gets, when you go from 0 to 1 to 2 to 3 to 4 to 5 to 6, or from -10 to -9 to -8, anytime you're moving to the right on the x's, the y is moving up. So this is the increasing function. The larger x gets, the larger y gets. That's how you know it's increasing. All right. So creating graphs from verbal descriptions. Okay, so if we had to make a graph of that, and we just had a graph paper in front of you, and you're like, okay, I told you this, that Zora wants to purchase some DVDs at $21 each. You got to purchase a gallon of milk. What would the graph look like? Well, you know, it starts at 0 DVDs and crosses at 3.5, because $3.50 is when no DVDs. And if she buys 1 DVD, you know, it's a slope of 21. So it goes up 21 over 1. So now the 3.5 becomes 24.5 because we added 21. And the x goes from 0 to 1 because now we bought 1. If we buy 2, we're going to add another 21 onto the y, and so forth and so on. All right, and this will walk you through those steps that we were just talking about. All right. Did you notice the graph contains only positive x values? Notice it stopped there. It didn't go to the left because she's not going to spend 0 money. All right, Kellen. Not going to spend 0 money. So the domain is non-negative integer. She's not going to buy -1 DVDs. So we have to restrict our domain and range that the x cannot be less than 0 because she can't buy negative DVDs, and the y cannot be less than 3.5 because she's got to spend a minimum of 3.5. So if we look at the restrictions on the domain and range for this scenario, the domain and range are restricted. Okay, let's look at the next page. All right, let's look at another scenario. Russell notices there's 12 bananas in the kitchen. He eats half a banana with his breakfast every day. So sketch a graph showing the function of bananas in the kitchen per day. So the first thing we have to do is like, all right, where's our starting point? When x is 0, 0 days, how many bananas are there? Right? Our y-intercept is going to be 12 because at day 0, there are 12 bananas. Then as we move to the right with our x's, one day, now there's how many? 11.5 bananas, right? So we should have a graph that starts at 0, 12, and each day goes down to half. See, that went down to 11.5. Day 2, we're at 11. Day 3, we're at 10.5. Day 4, we're at 10, and so forth and so on. All right, so we could sketch a graph if we just know the word problem. If we know what the scenario is, we can create a graph. So what's the domain of this function? The x's. Well, it is 0 and larger, right? X cannot be less than 0 because we don't have -1 days. The domain is all positive numbers. That's how it cannot be no negative numbers. All positive, not all numbers, all positive numbers. It is possible for Russell to graph the number of bananas he's eaten in a fraction of a day, but not a negative number of days. So basically x is greater than or equal to 0. So it has all positive numbers. And so Russell's domain, non-negative numbers. That's another way of saying it. Non-negative numbers, all positive numbers, et cetera, et cetera. All right, so comparing functions. Here's where it gets down to the gravy right here. We could have a function presented as an equation right here, which that's Zora's DVD function right there, right? Could be a graph. There's the same thing as a graph. Could be a table with 0 DVDs is $3.50, and 1 DVD is $24.50. Or it could have the written word problem. All 4 of these are exactly the same because they're all about the $21 plus $3.50 for the gallon of milk. Here's a graph of the same function. Here's a table of the same function. Here's the verbal expression of the same function. So you need to be able to compare and look, if I have a different graph and this, what's the difference between the y-intercepts? What's the difference between the slopes? These are both positive because these are the exact same one. These are increasing. These are increasing functions. So here's a video to learn more about comparing functions. Again, we won't watch this because you got access to this. You can watch this video. And this talks about 2 minutes and 52 seconds about comparing functions. So it gives you a verbal description, algebraic equation, table, graph. All right, so let's talk about all of that and being able to compare. Here's comparing an equation to a graph. It's all in this video, so you can watch the video and learn how to do that. Because your assignments, you're going to have this in your tests and stuff. Comparing functions, you got to be able to compare them. Well, this function and this function both have a positive slope of 2. Where this function and this function both have a negative slope of 5, or whatever the situation may be. So when you compare these, based on their slope, looking at these 4, which of these have the smallest slope? Well, let's see. If we look at this, this is 14 is the slope here. This goes from -5, and when this goes to 1, it's at +5. So this has a slope of 10. It rises 10 and runs 1. So slope of 14, slope of 10. How about this? As it goes from 1 to 2, it goes from 4 to 12. So the slope went up 8 right there. And this one, he has a job that pays him $12.25 per hour. So you know the slope. It's $12.25 because for every hour, it goes up $12.25. So the smallest would have to be the 8, right? This would be the smallest. Oh, I guess I can drag that there, smallest. J of X was the smallest. Largest, the largest was the 14. And then the smaller and larger between the other. This was 10. And this was 12.25. Correct. There we go. All right. So you can reset that. But yeah, you look through those, and this is just comparing the slope. Example 2. This time, same ones. Do the same thing using their y-intercept. So compare them down here. Here's our lesson summary, again, for your notes, or your viewing pleasure. Finding key features, slope, y-intercept, is it increasing or decreasing? How do you compare them? Algebraically, graphically, table, or verbally? There's notes. Also, I would have in my notes, if I wanted to have good notes for the test, I would have a sample problem where I had all 4 of these, and I would write the comparison underneath them. Right, I would have an example in my notes that I can use, and I would compare their slope, I would compare the y-intercept, and I would compare which ones are increasing and decreasing in my notes, just so I have that. They have 1 page of practice. All right, so these are all you try, and it gives check my work, gives you the answers. Here's one where you compare all of them based on their slope. All right. So there is plenty of practice problems right here to make sure you're understanding before it counts. Lesson summary. All right, let's look at the assignment real quick, and then we'll let you guys go. Comparing functions. What do we have? Which one of these is the graph of this? Okay, so which one of those would be the graph? Here's another one. Which one of these was the graph? Which function has the largest slope? And it gives you a table, it gives you an equation, and it gives you the verbal description. Which one of those has the largest slope? Which of these has the smallest slope? This is a function, a graph, and a table. Which has the lowest y-intercept? That'd be the smallest one between these. So that's it. 5 problems. 5 problems for you right there. That's it. That's what you got for the week. Don't forget, you got the quiz, and then you have these functions. You're writing the equation of a line and then comparing them. And then next week, we're actually to the end of the first module test. So we're going to finish the first module and get moving on with the rest of the year. So, all right. Any questions? All right. You guys have several examples and some videos we didn't watch in class in there for you. I didn't want to take extra time, but that's what you've got. If you do grades today at your grade check and your grades below 70, I'll see you Thursday and Friday. Otherwise, I'll see you next week. So have a great day, guys. Parent-teacher conferences tonight.